All right, guys, this is our last section in chapter 1. And so we're going to talk about inequalities, a couple of different kinds of inequalities. Inequalities as opposed to equations. So an inequality is a less than or equal, a greater than, or a greater than or equal. Okay, but we still have this equality relationship. So this is still something that we can consider being solvable, unlike an expression where there's only one side, right? We don't have an equal or a less than or a greater than. We can't solve those things. Okay, so the first kind of inequality we're going to talk about are quadratic inequalities. Okay, so it looks just like a quadratic equation, except instead of an equal sign, it's replaced with an inequality. Okay, so here's the steps for solving a quadratic inequality. Just like if we were going to factor or use the quadratic formula, first of all, we got to make sure the inequality is set less than or greater than 0, right? So all the terms on one side. This is really, really important, okay? It's really interesting. We're also going to factor. Again, we factor for everything, but for totally different reasons. It's so interesting. Okay, so when you factor, it must be set equal to 0, because if you're multiplying two things together, the only way they can equal 0 is if one of them's 0. But when you've got an inequality, let's just use the less than example. It doesn't really matter. But if if you have two things multiplying together, so that's why we're going to factor again. Okay, and if you want to know if it's less than 0 means negative. And think about this, when you're multiplying things, all I need to know are the signs. If I knew this was a negative number and that's a positive number, I don't care what the numbers are, then I know if I multiply them together, this whole thing is less than 0. Right? So once again, it's got to be 0, and we've got to see those factors, but for totally different reasons. So we're going to solve the corresponding quadratic equation, right? The equation. So to start with, we're going to imagine if there was an equal sign in there. That's going to give us two solutions, and we're going to make a number line table and use some test values. Okay, and then we're going to write our answers in interval notation. All this we'll go over in our examples. Hopefully you already know what interval notation is also. If you need some help with interval notation, let me know. Okay, so here's our first example. Okay, it's got to be set to 0, and this one already is, so we're good with that. So I'm just going to imagine initially that I'm solving the quadratic equation. Okay, x squared minus x minus 12. So I'm going to try to factor that. Two numbers that multiply to give 1 times negative 12, so negative 12, and add to give negative 1. I get a shortcut because my leading coefficient is 1, so I can just put my numbers in here, x minus 4, x plus 3. Okay, equals 0. That means we've got x is 4 or x is negative 3. Now, these are my boundary. These are the places where it's actually equal to 0, it being, our equation, our original problem, where it's actually equal to 0. But I don't want where it's equal to 0. I want where it's less than 0. So I'm going to make myself a number line. The only place that my equation can change from positive to negative is if it goes through 0. So if these are the values where this equation equals 0, then on either side of this, it's either going to be all positive. Think about a number line, right? On this side, now, not to be mistaken what I'm about to say here, I'm going to imagine this is just a regular number line, not a number line associated with the answers to this equation, but a regular number line. Think about this. Everything on this side is positive. I don't care how far out here you go, it's positive. Everything on this side is negative. The only time that you can change from a positive to a negative is if you went through zero, right? Everything on one side of zero is negative, everything on the other side of zero is positive. So these two values represent where this equation is zero. So all I need to do now is check, well, is it positive or negative on this side? Is it positive or negative here? Positive or negative there? Now, I'm going to imagine this is a number line, so our order is important. I have to write the smallest number first. And then I'm going to get a couple of test values. And a test value is just any number in this section. So let's just say a number less than -3. Let's choose the easiest one on that side, -4. A number in between -3 and 4. The easiest one is 0. And a number bigger than 4. The easiest one is 5. I could put 300 over here, but it's just easier to work with little numbers. And anytime I can plug in a 0, that's easier. Okay, so these are my test values. Okay, and I'm going to test the sign of each of these factors, because if you multiply, if I can find out this is negative and that's negative, oh, then I know the whole thing is positive when I multiply them. So I'm going to test, didn't give myself quite enough room here. I'm going to test x minus 4 and x plus 3. Okay, so I'm going to plug in a -4 here. -4 minus 4 is negative. I don't care what number it is. I just want to know if it's negative or positive. And think about this. It wouldn't matter what number less than -3 I plug. If I plugged in -20 minus 4, it's still negative. -4 plus 3 is negative. So in this section, I would have a negative number times a negative number. This is positive. Right here, if I plug in a 0, that's a negative, and 0 plus 3 is a positive. So when I put it all together and multiplied a negative number times a positive number, I'd get a negative number. Okay, in this section, I've used 5 as my test point. 5 minus 4 is 1. 5 plus 3, oh, I don't care what it is. I just want to know if it's negative or positive. Okay, so 5 minus 4 is positive because it's 1. And 5 plus 3 is positive because it's 8. A positive times a positive is a positive. Now, let me warn you. It doesn't have to change signs when it goes through 0. But if it's going to change signs, it has to be on either side of this. Think about this. If we had a graph of a quadratic, some of you may or may not know about graphs or quadratics, graphs of quadratics, because we haven't talked about it yet. So here's an example, right? Here's the 0. It's positive, it goes through 0, it's negative, and it changes. But it doesn't have to change. It could be positive on this side, hit 0, and then stay positive. So be aware of that. It doesn't have to change, but if it's going to, it has to be on either side of a value that makes it 0. Okay. So every single inequality quadratic is like this. I make it an equation, okay, find my zeros, make a number line chart with test values, and then determine where it's positive and negative. And now, for the first time, I really go up and pay attention to what kind of inequality I have. I don't really care until I get my chart built. Okay, so less than means negative numbers, less than 0. Less than 0 is the same thing as saying a negative number. So that means here's where it's negative. Now, if I had an equal sign, I would want the parts where it actually equals 0 to be part of my answer also. But here, I don't want where it's less than or equal. I just want where it's strictly less than. So I'm not going to include -3 and 4 in my answer. Okay, that means that from here to here, any values from here to here are my answer, not including the actual boundary line of -3 and 4. So when I write my answer on interval notation, if you do not have an equal sign, you put a parenthesis. If you do have an equal sign, you put a bracket. So what this is saying is anything in the interval from -3 to 4, right? -2, -1, 0, 1, 2, 3, in addition to 1.9, -4/5, anything in that interval will satisfy this problem. Okay, let's try that again. Okay, this one is already set to 0. So I'm just going to try to factor it because it's quadratic. I need two numbers that multiply to give -24 and add to give 5. I don't get my shortcut, so I've got to rewrite it. 2x squared. My numbers are 8x and -3x, right? 8 times -3, -24, 8 minus 3, 5. 8x minus 3x minus 12. And really, at this point, since I'm just trying to find my zeros, I can change that to an equal sign. Okay, now I can factor by grouping. Factor out a 2x. That leaves x plus 4. Factor out a -3. That leaves x plus 4. Okay, now I can factor out the x plus 4. And that leaves 2x minus 3. Okay, so my zeros are x equals -4 and x equals 3/2. Okay, just I might want to keep in mind that that's 1.5 when I make my chart. All right, so I'm going to make myself a number line chart. And I'm going to make these numbers be my boundaries. So -4, be sure you put them in order, and 1.5. Okay, and I'm going to be testing each of these factors. So I'm going to be testing x plus 4 and 2x minus 3 in each of these intervals, in each of these sections. So I need a number less than -4, let's say -5. I need a number in between -4 and 1.5, so that's 0, and bigger than 1.5, let's say 2. Okay, so if I plug a -5 into this factor, -5 plus 4 would be negative. If I plug a -5 in here, I'd have -10 minus 3, that's also negative. Okay, a negative times a negative is a positive, so in this interval, this problem is positive. Okay, let's try 0. 0 plus 4 is positive, and 0 minus 3 is negative. A positive times a negative is negative. Now, it's just a coincidence that this chart looks the same. Once again, they may not always, most of the time they change. But 5–10% of the time, it doesn't change signs. But if it's going to, it'll be on either side of this 0. But it doesn't always start with plus, minus, plus, so don't think that. You know, this could be a negative to start with. It just depends on what your original equation is. If I plug in a 2, 2 plus 4 is a positive number. And if I plug in a 2, 4 minus 3 is a positive number. So a positive times a positive is also a positive. Okay, now for the first time I go back and look at which parts I actually want. Greater than 0 means positive numbers. All the numbers that are greater than 0 are positive. Okay, so I want all of these numbers and all of these numbers in those sections where it's positive. This time I also want to include the zero values. So if I've got an arrow going all the way to the left on a number line, that is negative infinity. So it's going to start at negative infinity and it's going to go all the way to -4. Now, because it has the equal sign, I'm going to put a bracket. If it didn't have the equal sign, I'd put a parenthesis like we did last time. And then because I've got two separate ones, here's the symbol. This is the set notation symbol that means or. That means or, right? And so we write it like this, or. So it can be over here, or my answer could fall in this interval. Okay, again, I want to include that 3/2. I'm going to change it back to the way we really want it to look. And then I go all the way forever. In that direction is infinity. Now, infinities always have to have parentheses. Always, always. Because they're not a number you can include, right? And infinity is not a number. It goes forever and it never stops. So there's not a number to include. And if I put a bracket on it, it would mean and include infinity. Okay, so anything in the interval from negative infinity all the way up to -4, including -4, or from 3/2 all the way through infinity, including 3/2, would be a solution to this problem. Okay, so now we're going to do rational inequalities. Okay, rational inequalities are very simple. Rational, remember, means fraction. So if I'm working with a rational inequality, I'm going to have a fraction involved. Okay, so same thing. It's got to be set greater than 0, of course, because the only way we can tell, just because a number is less than 4 doesn't tell me if it's positive or negative. So it doesn't help me. It's got to be set to 0 to begin with. Okay, a common mistake, be careful about this. A common mistake is people see a fraction and they say, oh, let's multiply by x minus 1 and get rid of that fraction. And if this was an equal sign, I could do that. You bet. If it was an equal sign, I would do that in a heartbeat. But I can't do that if it's an inequality sign, because remember, if you multiply through an inequality sign with a negative number, you got to change the sign. And if I have a variable down here, I don't know if it's positive or negative. I don't know what x minus 1 is. So I can't multiply through. Now, if I had an equal sign here, I'd multiply by x minus 1. And if I just had a number here, if it was just -1, I'd multiply and change that sign. If it was 7, I'd multiply. Okay, but be careful about that. If it's an inequality, we have to get everything on one side, 0 on the other side. And then instead of factors, we're going to have the numerator and the denominator where we determine when they're 0. Because think about this, if I'm dividing a number, I also know, I know it's going to be positive because they're both negative. Okay, and then we're going to do the same thing. We're going to make our number line table, do the test values. Now, one thing we got to remember is that denominators can never be 0, right? You can't divide by 0, you can't divide by 0. So it does not matter if we have an equal sign when it gets to the denominator. If one of these solutions was 1, even though it said an equal sign, I got to put a parenthesis on it because I can't include 1 as a solution to this because it would make the denominator 0, and you can't divide by 0. Okay, let's do a couple of examples. All right, first thing I got to do is set it to 0. Has to be set to 0. So I'm going to subtract 1 from both sides. Don't make the mistake of multiplying by x plus 4. If it was an equal sign, yes, but not with an inequality. Okay, so I'm going to subtract 1. Now I'm going to go ahead and, I won't until, I was going to go ahead and make it an equal sign, but just for, okay, subtract 1. Now also, I have to have everything being either multiplied or divided. When I'm adding and subtracting numbers, I can't tell if they're going to be positive or negative without knowing what the numbers are, right? If I'm multiplying and dividing, all I need to know are their signs, and I can tell you the sign of the final answer, okay? But not when you're adding or subtracting. So I've got to combine these numbers into one fraction. That means if I'm adding fractions, I need a common denominator. So I'm going to, and the only denominator is x plus 4. So I'm going to make this 1 x plus 4 over x plus 4, right? It's the same thing as 1. Okay. Now that they have the same denominator, I can combine them. And then on the top, I have 5. Watch out for this negative sign, right? It's as if there's invisible parentheses around this numerator. I have 5 minus x minus 4. Okay, so that's 5 minus x plus 4 over x plus 4 greater than or equal to 0. And then 5 plus 4. So I have 9 minus x over x plus 4. And at this point, I'm going to go ahead and make it my equation. Doesn't really matter on this one because I'm not factoring or anything. So it doesn't really matter. Okay, and what I want to do is I want to know, well, what makes the numerator 0 and what makes the denominator 0? So I want to know, when is 9 minus x 0? When is x plus 4 0? So right here, if I add x to both sides, if x is 9, or if I subtract 4, x is negative 4. Okay, that's going to give me my number line values. Negative 4 and 9. And my test, what I'm testing, is the 9 minus x and the x plus 4. Now I need some test values. A number less than negative 4 is negative 5. A number in between negative 4 and 9 is 0. A number bigger than 9 is 10. Okay, I can choose any number in those intervals. All right, now if I plug a negative 9 in here, a negative 5, 9 minus negative 5 is 9 plus 5, that's positive. Negative 5 plus 4, okay, negative 5 plus 4 is negative. A positive divided by a negative is still a negative. 9 minus 0 is positive. Okay. 0 plus 4 is positive. And a positive divided by a positive is a positive. 9 minus 10 is negative. 10 plus 4 is positive. A negative divided by a positive is a negative. Okay, so now for the first time, I go back and try to determine what I actually want, and I want the positives. Okay, greater than 0 means positive numbers. That means this time I want this in between section again. And because it says or equal, I want to include these numbers unless it would make the denominator 0. So I do not want to include the negative 4. It will get a parenthesis because if you tried to plug negative 4 into this equation, right, it's not going to work. So negative 4 all the way to 9 and include 9 in your answer because it's okay for the numerator to be 0. It just means the entire fraction is 0. Okay, let's do it again. Okay, what's the first thing we got to do? You got it. We got to set it equal to 0. So 2x minus 1 over 3x plus 4 minus 5 is less than 0. Now what? Right. We can't have things being added or subtracted, only multiply or divide. So I need to make an equivalent fraction and add them together into one fraction. So my denominator is 3x plus 4. Okay, which means if I put this on a denominator of 3x plus 4, I also have to put that in a numerator, right? Making an equivalent fraction. So I would have 2x minus 1 over 3x plus 4 minus, and then I'm going to have 5 times 3x minus 4 over, not minus, it's a plus there, over 3x plus 4. All right, got to multiply top and bottom by the exact same thing to make it equivalent. Okay, I could cancel those out and I'd be right back at 5, less than 0. All right, let's distribute this now. I've got one denominator that's the same, so I can put it all over the same denominator. Let's see what my numerator is. Just combine the numerators. So we have minus 5 times 3x minus 15x minus 5 times positive 4 minus 20 less than 0. So 2x minus 15x, we've got minus 13x. And then negative 1 minus 20 minus 21. All over 3x plus 4. Less than 0. Okay, so now I just want to know, well, what makes the numerator equal 0? Because that's where it could change signs. And what makes the denominator equal 0? Because that's another place it could change signs. So over here, this would give us x equals negative 21/13. Okay, add 21, divide by negative 13. So I want to kind of know for my number line where I need to place this. So I'm going to say, well, that is negative 1 and what, 8/13? I don't have to work with these actual fractions. I can pick a whole number in between them. And then this is x equals, okay, negative 4/3. Oh, I might have to work with them. Negative 4/3, negative 1 1/3. Okay. All right. So now I need to make myself a number line. First of all, I need to know which one of those is larger. So I might have to go up here. If I can't tell from this, right, I might have to get a common denominator. Let's make 8 and 13 and 3. That's going to be 39. So let's take our 8/13 and make it have a denominator of 39, right? Just like we did here. Multiply the same thing to numerator and denominator. So that's 24 over 39. And then let's do the same thing with 1/3. Let's multiply it by 13. So we have 13 over 39. Okay, so really, this is, we can call this negative 1 and 24/39. And this is negative 1 and 13/39. So negative 1 and 24/39 is smaller than -1 and 13/39, right? Because it's more negative. Okay, so if I want a test value, a number less than -1 and something, let's use -2. A number bigger than -1 and something is 0. But right here, I'm going to have a number -1 and let's say, I don't know, what you can do anything 20/39, anything in between there. Okay, and what I'm going to test is -13x minus 21 and 3x plus 4. Okay, so I'm going to plug a -2 in. -13 times -2 is positive 26 minus 21, that's positive. Okay, -6, because 3 times -2, -6 plus 4 is negative. A positive divided by a negative is negative. Let's skip this one. I'm going to erase this and we'll have some room over there to work with that. If I plug a 0 in, okay, 0 minus 21 is negative, and 0 plus 4 is positive. A negative divided by a positive is negative. Okay, so let me erase some of this over here so we can see how we might get an answer for that, which seems like a crazy fraction. Okay, let's do this first and plug in -1 and 20/39. I don't think it's going to be as bad as you're thinking, because that 13 and that 3, the reason we have that denominator, it's going to cancel easily. So we have -13, and then times, actually, let's make this, since I'm going to work with it, let's make it a mixed, an improper fraction. So 39 times 1 is 39 plus 20, so this is 59 over 39. So -59 over 39 minus 21. So notice what happens here. This 13 and this 39 can divide out and leave a 3. Now they're both negative, so we have 59 thirds, negative times a negative, 59 thirds minus 21. Once again, I don't really want to know exactly what this number is. I just need to know if it's positive or negative. So let's see. 59 divided by 3, that is 28 and something, right? No, 18. Okay, 18 something. So this is smaller than 21. 59 divided by 3. 3 goes in that one time. 29. Yeah, 19. So this whole thing is negative. Okay, you can go as far down as you need to work that out. Maybe we should see what we're doing here. So I'd get a common denominator if I needed to. If I couldn't just do what we did there. Okay, so I'd have 59 over 3 minus 63 over 3, and then notice, oh yeah, it's negative. 59 minus 63, negative. Okay, let's do the same thing except with the other. Okay, so 3 times negative, what do we say that was, 59 over 39? 59 over 39. That pen had something scratchy on it. Plus 4. Once again, the 3 and the 39 will simplify. So we have negative 59/13 plus 4. And at this point, if you can figure out which one of these is larger and determine if it's positive or negative, but if we need to go all the way down, then what we would do to combine these is make an equivalent fraction by multiplying the numerator and the denominator by the same thing. So we'd have negative 59/13 plus 52/13. So the entire thing would be negative. Negative 59 plus 52, negative. A negative divided by a negative is a positive. All right, so now for the first time, I need to decide what answer I actually want. So I go back and I want less than 0. That means I want the negatives. I don't have to worry about that denominator this time because I'm not going to include either value because it doesn't have the equal to. It's strictly less than. So both of these are going to get parentheses. But remember, if it had the equal to, it doesn't matter if it had an equal to. This value would never get a bracket on it. So the arrow means infinity. So negative infinity all the way to -1. And write your answer in the simplified form, right? So -1 and 8/13. Make sure you get the corresponding one. Parenthesis, or -1 1/3 all the way to infinity, also with a parenthesis. Okay, that finishes up chapter 1. Right, finishes chapter 1, so next time we'll be beginning chapter 2. Let me know if you need anything.